Hi, Mrs. McTaggart here. In this video, we're going to look at national 5 percentages and we're going to look at the appreciation and depreciation questions. So these are generally question 1 in your paper 2 exam, and we call them bread and butter questions because they're worth 3 or 4 marks, and for a lot of people they are the simplest marks to get in the whole paper if you can remember how to do this process. So the lesson intention is to be able to find the value of an item after it appreciates or depreciates by a given value for a number of years. Now, first thing we have to do is explain what these words appreciate and depreciate mean, because they might be completely new words to you. I know everyone understands what appreciate means in context outside of maths. If you appreciate something, you're thankful for it. But in maths, it's a bit different. I'm going to talk about depreciates first because most people recognise that one first. And I would then talk about all the different words that sound a bit like depreciates, like decreases, depletes, deprives. They all talk about things going down, don't they? So depreciation is the exact same. If something loses its value over a period of time, we say it is depreciating in value. So in that sense, appreciation is the opposite. So a wee statement here that was worth always copying down is that appreciation is a rise in value, depreciation is a decrease. Okay, quite simple to remember. Now the process to do this, I'm going to show you 3 different ways to do it. So let's have a look at my first example. So an antique clock is valued at £400. It's expected to appreciate in value by 7% each year. Find its value after 7 years. So what this means is it doesn't mean that we simply find 7% of 400 and times it by 3. That is not national 5. If you're wanting to do that 7% equals, what would that would be 28, and then times that by 3 and say that that's your interest, then no, you are wrong. That is not national 5. That is national 4 type questions. What is actually happening is at the end of the first year, this clock has gone up by 7%. So it goes up by 28 in its first year. Then in the second year, it starts at £428 and it goes up by 7% of £428 again. So I'm going to show you the working for this, doing it the really long way. So here it is. So in year 1, we've worked out that the interest is 27. We've added that on and got 428. We then do the exact same process again for year 2. We find 7%. Now you obviously have a calculator for this one, and you're doing some combination of 7 divided by 100 or 0.07, whichever you're comfortable with. We get the new value of the interest is £29.96, so slightly more than it was the first year because your starting value was more. Your clock was now worth 428, so the increase is slightly more. So by the end of year 2, this clock is now worth 457. We do the same process again, find 7% of that new value. It goes up by £32 again, so again a slightly bigger increase. And then the final price of this clock is £490.02. Now that is an awful lot of working for 3 marks. You're effectively doing 6 sums there. You've got a percent and add on, a percent and add on, a percent and add on. Okay, now there must be an easier way to do this. So we're that used to in maths of finding the percentage first, getting that value and then adding it on to your original amount. So if you think of that original amount as being full price means you're paying 100%. So if the original amount is 100% and you're adding on whatever 7% of that is, then that value at the end of year 1, this 428, well, that's the equivalent of 107%. Now, instead of finding 7% and adding on, why don't we just find 107% of 400? So 107%, at some point you're going to have to divide that by 100 or turn it into a decimal. So 107% as a decimal is 1.07 times by 400. Now, if you do that, you get the 428. So what we have done there, we have converted that top line, the first 2 sums into 1 sum. Let's show you this in more detail. So this is the second version here. So this is version 2 and this is version 1, just shown again on the screen for you. Look at the decrease, it's half the working. So what we're doing is we're now decided, instead of finding it all the wee interim bits like 7% and adding on, we're just going straight to 107%. So we're times by 1.07, we're timesing our answer by 1.07 again, and then we're timesing our answer by 1.07 again, and look, we still get to the same value. And generally at this point when I show this to my pupils, like, oh yeah, much prefer that way, look at that, 3 lines of working. But then we ask, well, does anyone spot an even quicker way of doing this? I mean, on my calculator, I probably did 1.07 times 400. And then I'm very good at just leaving things on my calculator screen. And then I probably did times 1.07 again. Got that answer, 457. And then I times by 1.07 again. And then when I write this out to my pupils, they start to say, well, wait a minute. You times by 1.07 3 times. What is the mathematical thing called for when you're multiplying repeatedly by the same number 3 times? Well, you're doing it to the power 3. You're cubing it. So then we say, well, why can't you just do 1.07 cubed times 400? And then I get my class to get the calculators out and I say, go try that. Go type in 1.07 cubed times 400. And they're astounded to find that yet again, it gives us this same answer of £490. In one sum. One sum with basically 2 little bits to it. Is that not amazing how you can go from that big one to that little one? And it only works if you understand why we are doing this. Where does 1.07 come from? Why are we cubing it? Now, there's another connection there with the cube. I was asking for the value after 3 years, so I had to do this sum repeatedly 3 times. Power 3, 3 years. The power is connected to the number of years. So what we've got then is, I say, well, there's a general kind of formula for this. If we are doing an appreciation question, we do this thing here. So we're looking at this. So whatever percentage I tell you the item is going up by, you add it to 100. So in that example there, I had 7% added on to 100. And we said, well, that's 107%. To turn 107% into decimal, we do the divide by 100. So my multiplier for that first one was 1.07. And I did it to the power 3 for 3 years. Let's change that question though, and I'm going to say that my antique's not doing too well. My antique is going to depreciate now by 7%. So you do the exact opposite to what you did. You don't add on to 100 anymore. You take off. So instead of finding 7%, take it away, 7%, take it away, start by thinking, well, the full price was 100%. If I take off 7%, I'm left with 93%. 93% as a decimal, divided by 100 is 0.93. And then it would be for 3 years, so we do the power 3. So this here is a difference. This one is up by 7%. This one is down by 7%. So all appreciation questions will be getting multiplied by 1 point something, and all depreciation ones will be 0 point something, because for something to go down in value, you have to be timesing it by something less than 1. So I'm going to show you some examples of this in action and let's actually try them out. So for the first one, I've got a flat that in 2018 cost £75,000. We've been told that it's going to appreciate in value by 8%. So appreciate means that it's going up. So that's the first thing you have to be aware of in your head. We're going up by 8%. So how much is it now worth? So if this was, remember your original value is 100%, you're going to add on 8, which gives you 108%. Now as a decimal, you put that over 100, that gives you 1.08. In this bit, I never really get pupils to write down. This is me talking about what the process should be in their head to get the multiplier. And the more you do this, the quicker you get it. Say, no, up by 8%, 1.08. Up by 10%, 1.10, or just 1.1. So my multiplier going up by 8% is 1.08. Now, how many years is this for? Well, 2018 was 3 years ago, because I'm making this video in 2021. So that means it's got a power 3 again. And then I times that by the money, which is the 75,000. And I get my answer of £94,478.40. Now it's worth pointing out that quite often in percentage questions they'll ask you to round that to significant figures, to the nearest pound, to the nearest £10. So always watch out for rounding. If there's no rounding and it's money, well, it makes sense to do to 2 decimal places because that's how we do money. So please watch your rounding on these ones, okay? So that's my house going up by 8%. Let's do one that's depreciating now. So 2. A set of golf clubs costs £600 and are rumoured to depreciate in value by 15% each year. So these golf clubs are going down in value by 15%. We want to know the value after 4 years. So if it's going down, you are in your head, you're thinking, right, well, 100% was the £600. If I take that down by 15%, then the value at the end of year 1 is 85% of what it used to be. So 100 taken by 15 is 85%. As a decimal, that is 0.85. So that is our multiplier. Now, the next bit is, this one's slightly different. It's saying that I want the value after 4 years. So we put a power of 4 on it, and we times that by the money. So we stick on the 600. Now, it's worth pointing in your calculator, you don't have a power of 4 button, so you're looking for a button. If you've got a Casio or a newer version Casio, you're looking for a button which is X with a blank square. If you've got an older Casio, it might be one with a little pointy arrow like that, which is how we do power, maybe when we're typing a Word document, if we can't, or in Google Classroom when we can't reply to something with powers in it. If you've got a Sharp calculator, I'm pretty sure it is a Y with a power X or an X with a power Y. It's one of those ones. That is your blank power button, right? So it will let you put in anything like power 4, power 6, power 10, whatever you have to do. Just watch if you've got a newer calculator, you might have to play about with your little cursor wheel, because when you put in the power bit, it might want to like put the times by 600 up here onto your calculator screen. See the way I've done it with the 4? So you maybe have to play about the cursor button to bring that times sign back down to normal size. You'll know what I mean if your calculator does that. If not, don't worry too much about it. So to do this then, you do 0.85 to the power 4 times 600. I'm just typing in my calculator to just now. And it gives me £313.203. So I'm going to say 20 pence for that one. So that is the value of my golf clubs at the end of 4 years. And you'll notice that they've almost gone to about half the value by then. Which leads us into my final question. The rare used to come up in the olden days before National 5 was they'd give you a question and say how long until an item halves in value. So a car loses 18% of its value each year. If it's worth £9,000 new, how long until it is worth half of that? Well, the first thing I'm going to write down is, well, what is half of 9,000? So I am looking for it to be, I'm looking for the car to get to £4,500. So our aim is to reach £4,500. Now, there is no kind of shortcut to do this. You have to do the longer way. You could play about keeping putting in the powers, or you could do what I'm about to suggest just now and just do it a year at a time. So in year 1, if it's going down by 18%, remember 100 take away 18 is 82. So as a decimal, that would be 0.82. So I'm going to do 0.82 times the 9,000, which on my calculator gives me 7380. Now year 2, I'm going to do the exact same sum. I'm then going to do 0.82 times that value. And it's going to give me 6051. And all I did was I kept that number on my calculator screen and I times it by 0.82. For year 3, I'm going to skip the work in and I'm just going to type times 0.82. Gives me, 4962. So we're nearly there. Now at this point, well, it's pretty obvious it's going to take 4 years, but you can't assume anything. You have to then actually work out the value for the 4th year to prove this. So times again, and by year 4, the value would be 4069. It's 0.95, so 10 pence. So my working clearly shows that I was looking for it to be 4,500. I've now got it down to under 4,500. 4,500. So my conclusion would be it takes 4 years to fall below £4,500. And the year that this came up one time, the marking scheme for it was quite strict. If a pupil had stopped here and then said, oh, it'll then take 4 years, we couldn't give full marks, so we had to see your answer for 4 years. The other way you could do it is you could sit and do 0.82 squared, 0.82 cubed, 0.84, working it all out, but we really want to see this line of working. We want to see what your value is after 4 years. Okay, well, so that's me kind of covered everything you could be asked for. I hope you followed this okay with appreciation, depreciation. Honestly, once you get that multiplier bit, the rest is really straightforward for these. Thank you. Bye-bye.